in your notes, head back to example 5 and look at all the work that we had to do in order to build the Maclaurin series for e to the opposite of x squared. All right? It took a lot of deriving because each derivative was involving the product rule, the chain rule, or some combination of both. We had to get down, in order to get 4 terms, we had to go a whole bunch of derivatives deep. All right. Well, look how much easier it is to get that series for e to the opposite of x squared now. We take our e to the x, in that series we modify it accordingly. So let's put e to the x on the board again. E to the x, remember, is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus so on and so forth. And then we had x to the nth over n factorial. Well, if I want e to the opposite of x squared, what's the difference between here and here? Well, I just plug in the opposite of x squared into every spot that I see an x. I'm creating a composite function. I'm putting an inner function into an outer function. The outer function is e to the x. I'm placing the inner function of the opposite of x squared in there. So if I plug in the opposite of x squared on the left side, all I got to do is plug it in on the right side for every occurrence of x. So I've got 1 plus, and then here's an x. So I replace it with the opposite of x squared, right? Plus, there's another x. So I replace it with the opposite of x squared. Plus, here's another x. Replace it with the opposite of x squared. All right, so on and so forth. All right, we'll get to the general term in a second. Let's simplify these terms right here. All right, 1 minus x squared. And then right here, I've got the opposite of x squared being squared. So that's going to become x to the 4th over 2 factorial. Okay. My next term, I have the negative 1 as being cubed. So I'm going to subtract, right? Because I know I have an alternating series. X squared cubed is x to the 6th over 3 factorial. Right? Plus, look how much easier it was to get those first 4 terms now that we can just take a series that we already know and manipulate it. Okay. Our general term, we have what? X to the, what are we doing here? We have, sorry, I want to do this. I want to do the opposite of x squared to the nth power over n factorial. Okay. If I need to simplify that, which I don't, I have 2 and n there, so I've got x to the 2nth. All right, I've got my negative 1 to the nth power, so I need to put that in right there, and then n factorial. Right? But you don't need to simplify. That's perfectly fine. Right? So we've created our 4 terms in our general term, and we did it much quicker than the last time around. And guess what? Now that we have this series, we can create a whole nother series. All right, we can create a series for the function e to the opposite of x squared minus 1. All right, what does that mean? Well, if you're subtracting 1, that just means you're adding negative 1. Right? So if we add negative 1 on the left side, we just add negative 1 on the right side. So negative 1 plus 1 plus blah, 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 blah. Well, guess what the negative 1 and the 1 do? They wipe each other out. There's your series for e to the opposite of x squared minus 1. And once we have that series, we can build off of that one, go on to another one.